Now, lecture 20, numerical example number 2. Here only I want to develop the wedge product. See? Now, given covariant components Tij, 242, 642, 82, and 2, and the vectors x and y. We need only two vectors because we are working with Tij. You see? Now, let's compute the symmetric and antisymmetric. Now, this map T here, Tij, dxi, dxj, and the map, okay, applied act on x and y, which is given. Now, let's proceed step by step from here. First, step 1, compute T symmetric and T antisymmetric. Recall that T symmetric is 1/2 Tij plus Tgi. You see, you just add and divide by 2 this matrix and then get what is there. On the other hand, the antisymmetric 1/2 Tij minus Tji. Also, you can make simple calculation, you see, and write the antisymmetric matrix. So, this is item 1. Item 2, let's develop, okay, this Tij. You see, there's only the antisymmetric. Why? Because the symmetric, this case, times dxi dxj is 0. Symmetric times antisymmetric is always 0. Okay, for any matrix. Okay, so this then I work only with this, the antisymmetric. It's 1/2 Tij minus Tji dxi wedge dxj for all ij. You see, there's a long derivation, but I prefer, okay, to develop this relation over here. So this I first add some, this is dummy, you see, dummy indices. You see, I just developed for I is equal 1, I is equal 2, I is equal 3. And then for each term, I develop j is equal 1, j is equal 2, j is equal 3. You see, you just look at here, okay, and copy. You see here first, you see for I is equal 1, you see I repeat j. I is equal 2, I repeat j. I is equal 3, I repeat j. You see, then for each term over here, I will sum, I will add j. You see, this will have 3 terms, this will have 3 terms, and this will have 3 terms. You see, I just wrote all of them right here. It's quite easy. And then I group, you see, the blue one with the blue one. You see, this is minus dx1, dx2. You see, this minus here, I have plus t12 minus t21. You'll be 2 times, you see, which is written right here. You see? So I group the green one, okay, with the green one over here. dx3 wedge dx1 is minus dx1 wedge dx3. This minus here reach this plus and minus, and I group with the green term. The same here with this pumpkin orange, okay, dx3 dx2. You see dx3 dx2 and dx3. So this is minus dx2 dx3. Quite easy. So then I combine this group. It's 2 times, okay, which will be cancelled with this 1/2 here. You see? So I can obtain just this simple algebra. You see? I just obtained, in this case, 1/2 here. This, there is no 1/2 because I simplified. So T12 minus T21, dx1 dx2 plus t1 minus 3t1 dx1 dx3, t2 minus t2 dx2 dx3. You see here on this line, this only for I less than j. You see, as I mentioned before. Now I substitute numbers. You see, I have t12, t21. You see, you just look at this matrix over here and see it. This will be 4 minus 6. This is 2 minus 8. And this will be 2 minus 2. Then this will be minus 2 dx1 dx2 plus this guy minus 6 dx1 dx3 plus 0 dx2 dx3, which is written there. So it's quite clear, no problem. Now the item 3, okay? Then there's a map. We act in the vector x and y. Attention, the map is just minus 2 dx1 y dx2 minus 6 dx1 dx3 plus 0 dx2 dx3, as is just I wrote over here. So let's apply, okay? Now item A, I use this term. Item B, I develop this term. So this one, remember, okay, dx1 act on x is x1. You see the component, okay, is equal to. You see here, this is equal to, just here. You see? Now, again, likewise, dx2 on x is x2, which is 3. You just written there. dx1y is 7, dx2y is 9. Okay, that's clear. Now, attention now. This here, okay, do remember the determinant, okay? I can write this as determinant. This will lead x1 y2 minus y1 x2, because I have dx1x dx2y minus the determinant, you see? So dx1y minus x2x. So then x1 y2 minus y1 x2. I just substitute. I have these numbers over here. You see? I just see there and substitute here. I will obtain minus 3. But item A, I have to multiply by minus 2. So minus 2 minus 3 is plus 6. The same is similarly for the item B. Item B is minus 6 dx1 dx3, acting on x and y. You see, it exactly is analogous, the same. You see? So this will be minus 6 x1 y3 minus y1 x3. Again, this over here, you see this over here, okay, I have to use the determinant, okay, just to ensure antisymmetric, as I emphasized in previous lectures. Now I substitute numbers. So this minus 6 that multiply 2 times 11 minus 7 times 5, which is minus 13. You just look at that. So multiply by minus 6 is plus 78. The answer is T acting on xy is 78 plus 6, which is 84. You see? So this is clear, an application of the wedge product. But now I have 3 by 3, the 3 by 3 matrix. 3 by 3. You see? You see all this is written clearly. You just copy and write down and check the numbers. See?